Hi, I'm Andrew, and this is part 4 in the Advent of Code series where I'm solving a daily code challenge in Kotlin. The previous videos are up on my channel in a playlist for Advent of Code 2022. If I'm able to solve any challenge today, the code will get uploaded to my repository. The link for that is in the description of the videos. So let's get to it. For day 4, this is going to be the challenge. It is camp cleanup. For camp cleanup, space needs to be cleared before the last supplies can be unloaded from the ships. So several elves are assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. As some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. So to try to quickly find big overlaps and reduce duplicated efforts, the elves pair up and are making a big list of the section assignments for each pair. That's the puzzle input. For example, consider the following list of section assignment pairs. We have 2 through 4 and 6 through 8. Um, for the first few pairs, this list means within the first pair of elves, the first elf was assigned. Okay, so these are the sections. The second elf assigned 6 through 8. So the second pair shows 2 through 3 and 4 through 5. And then in the third pair, they're each assigned 5 through 7 and 7 through 9. Um, So that's one where there is a shared value between them. 7 is in both ranges. Um, so this example uses single digit IDs, but we could also have larger values. So the pairs of section assignments look like this. It just shows in the chart. So here we can see what the overlap is. So some of the pairs have noticed that one of their assignments fully contains the other. So 2 through 8 fully contains 3 through 7, for example. Um, or 6 through 6 is inside of 4 through 6. So in pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections. Um, so we need to reconsider that. In this example, there's 2 pairs, and that would be this one and this one. So we don't need to check for the overlap. We need to check that one group contains the entire other group. And we need to count how many assignment pairs does one range fully contain the other. Okay, so I think we know what we need to do. Let's get the puzzle input and start writing some code for that. I have some ideas, but we'll see how it goes. Each line is going to be independent, so we can just check one line at a time. That simplifies things a little bit. But we do need to split out the groups, and it looks like we can use the comma in between to separate them, and then we're just going to need to take um, like a start range and an end range, and I think we could do that also by separating or splitting out by the dash. So we'll kind of split twice and then just create like a number range. So I think yeah, let's just get started with that. Um, the first thing we're going to want to do is split the assignment pair. So I'll create a function for that. An extension function under string for split assignment pair. And that's just going to return a um, we'll make it into a pair of string and string. For to do that, we could just take we can just call split, and we're going to do a comma, and we'll return that. This is going to be returning a list. Um, I guess that's fine. We could just make it a list of strings. And then we're also going to need another function for splitting out or for creating the range of values. So that'll be a little different. It's going to be, we'll say get number range, or we'll say get numbers in range. And that is going to return a list of integers. And what we could do is say it's going to take an argument of, actually it's not going to take an argument, we're already in an extension function, so for this we will return the split of a dash for the separator, and we'll just map it to an integer. And I think that should be fine. I'm just going to run it over the whole data set and make sure that there's no errors. So input, we will say for each, we will take it and split into assignment pairs, and then for each of those, we will get the numbers in range. And yeah, we're just going to run it and make sure there's no errors. I think all the values should parse fine. Yeah, so it ran. Then what else do we need to do? We need to we have, okay, so here, this is just going to return right now a list probably of 2, which is going to be the start and the end. But what we want is for it to be a list of all the values in between. So what we can do is make this into let's see. We can map this response and say the first value in a range until the second value. And it's still not liking that because this is a list of character ranges, so we still have to take it to map them to integers first. Okay. So then we could just take, oh, that's not what we want. Okay. Let's back up a step. So when we first split these, we're going to have a list of strings. And the list is going to be 2 characters long. It's going to be the first in the range and the last in the range, but they're strings. So we're going to convert them to integers, to integer. So now here we do have a list of integers, and we will again map that into a range. But we want to let, because we're not iterating on each one here, so we want to start here. Okay, so that's what I was doing wrong. We want to take the first index and start it in a range from, and the 2 of the range is going to be here. And again, it's not liking this, but that's because this is an integer range. So I think we could just make it a list of and put it in there. This, oh, no, we're still here. We want to maybe do this to list. There it is. Okay. And I'm just gonna do a sanity check here that the logic worked. We'll put our variable here and then return it so we can debug what the value is. So if I set a debugger, looking at what these numbers are. String that we're in is 24 through 66. So when we split that out, we should have a number list starting at 24, and it should go up until 66. It is inclusive, so that looks good. So now what we need to do is take both pieces of the pair, get their number range, and we just need to check if one contains all of the other one. So we can say let's see, we're going to need to return a count at some point. So let's just kind of start working that in. I think we could just do one function here. We'll take our input, we'll start with that, and map it or count. We will start by splitting the assignment pair. You know what? This could get confusing, so I'll just do it one step at a time, and then if we want to clean up the code later to kind of consolidate it, we will. So we will say pairs is input split split assignment. Why doesn't it like that? Oh, because we need to map it. Split assignment pair. And then we'll say the count is going to be start at 0. We'll just iterate through this here to make sure the logic is good. So for each pair, we'll say if we could take its get the number of range. Oh, that's still on a list of strings. We will want to let's see. We're getting a list of lists. Yeah. So that makes sense. So here we want to just separate it out. So we'll say set what were the values? What were they representing again? I forgot. Sections. Okay, so section list. Section list 1 is going to be the first index getting the numbers in range, and the section list 2 is going to be from the second index, getting the numbers in the range. And we will say some logic here. If one contains the other, then we're good. And we can increment the counter, and we'll just say that we're going to return the count. If section list 1 contains all of section list 2, then we can increment the count. Really, we could do that for either though, so we're going to just do an or if section list 2 contains all of section list 1. I think that's going to get us there. Let's run it and see what the output is. So it says there's 518 scenarios where that happens. The total list size is I think pretty large, so yeah, about half of them. I think that could work. We'll check it. And that is the right answer. Good. Okay, so for part 2, seems like there's still quite a bit of duplicate work planned. Yeah, I would say over half is a lot. The elves would like to know the number of pairs that overlap at all. So in the above example, the first 2 pairs, The first two pairs, 2 through 4, 6 through 8, they don't overlap while the remaining pairs do. Okay, so it's like a simpler version of what we were already doing. Um, in a single section. So, okay, so looking at this one overlaps. No, this one doesn't. This one does. 7 overlaps this one. They're in the middle. This one's here. Okay, so that could be nice. Let's just copy this over from part 1. So instead of checking that it contains all, we can just check contains any. I think all this logic is still going to work the same. Section 1 um, contains, or we'll say any. So if section list 1 has any that section list 2 contains, then that's where we are. So it's just a little update of that logic. We'll do the same thing here, but swap the numbers, or if list 2, great. We'll add some names here. Let's check that for our second value. Okay, so that makes sense. It would be a good amount larger. Let's check 909. Awesome. Glad to see that it wasn't too much of a brain teaser on the second part. Great. So that's it for today, and I will just follow up tomorrow with another video.